Year 12s, just going to do a video on that second part of the folio. I've rewatched that first one. It is a little bit confusing, and I think partly that's got to do with the shape of the graph. So I've changed the graph that I'm using to more accurately sort of show the type of the graph that you guys are going to be dealing with, and a similar sort of equation as well. So again, the idea of this folio is to actually determine whether a car is good value or not. Now, hopefully by now, you've actually figured out that cars below the line are going to be good value, cars above are going to be bad value. And I'm going to show you why that is in a minute. But what we're going to do to actually make those predictions is use this equation here. Now, the R-squared value is good for correlation. It tells us how in line or correlated our data is. But we don't actually need that for this part of the folio. It's useful when we're talking, doing our discussion and talking about our analysis, because remember, the higher our R-squared value, the more confident we can be about these calculations we're making. But for now, we're just worried about our equation of the line, okay? So we've got this graph here, and I'm going to pick this one down here as my car that I'm going to investigate. So what it says down there, just below the cursor, is that this car's done 60,000 kilometres and it cost $7,000. Okay. Remember, our x-axis should be, if you've done it the way I wanted you to, should be your kilometres, and your y-axis should be your price. If it's not, go back and swap your columns around where you've done your graph. So have your kilometres on your left-hand side and your price on your right-hand side, and then redo your graph, and it should be fine. So for a car that has done 60,000 kilometres, the cost we expect, or the trend line predicts, that is going to cost this much here, so roughly $17,000. But we know it actually costs $7,000, so we can already say that it's probably a pretty good deal because it's priced below what the predicted price is going to, or is going to say it is. But we want to actually calculate exactly what that figure might be. What is the exact predicted price for a car that's done 60,000 kilometres? And we can do that by taking our equation. So if we do y equals negative 0.0847, and all we're doing is just going to substitute, instead of x that we've got here, all right, we're just going to sub in the kilometres that particular car that we're interested in has done, which in this case is 60,000. And then plus 21,841. Now, if we do that in the calculator, which I'm going to do now, remember the minus, okay? The amount of times that people have got through the whole folio and haven't actually, remembered to put the minus in when they're doing these solving equations, and had to go back and redo all their calculations is incredible. It's, very, very often it happens. So hopefully you can see that. So I've just put that equation in there. It might be backwards for you guys actually, but the predicted price, once we've solved that equation, is 16,759. So it's close to the value we thought it was going to be, which is the first sort of tick that we've done it right. So this is our predicted price. So it's the price that our line of best fit, which is here, is telling us that it's going to be. And obviously, I showed you before, but I'll show you again. So if we go straight up, and straight across, we can see that that's roughly going to be 17,000. And this calculation just sort of confirms that. The predicted price is exactly 16,759 for a car that has done 60,000 kilometres. Now, this is where the value part comes in. We know that the purchase price, or the advertised price, you can call it either, equals $7,000, which is that little point down there. So 60,000 kilometres and $7,000 it's going to cost. So it's almost $10,000 less than our predicted price, which is exactly what you guys would say. You'd do 16,759, take $7,000, and you'd say this car represents, what's that going to be? $9,241 of value when compared with the predicted price. Okay. And what I want you to do is to do that for at least 2 cars below the line. I would be choosing the cars that look the furthest distance below the line because we know that they're going to represent the best value, and 1 car over the line. Now, hopefully you've picked up now that the further away from the line, either up or above, determines whether it's going to be really good value or really bad value. So this one up here, looks like it's going to be really bad value. So that would be the one that I would sort of investigate for that particular graph if you had one like that on yours. It doesn't really matter which ones you sort of choose to do, but that's the way I would be doing it. I'd be looking at your line of best fit and the distance away and picking the 2 furthest ones below and at least 1 above, and following this process here. So using our equation, inputting the amount of kilometers that certain car has done, solving that equation, so just writing it into your calculator and then pressing equals, and then comparing your predicted price with the advertised price. For this one here, the actual advertised price is $31,000, but if we go down to our line of best fit, it's telling us that it should cost slightly less than $20,000. Okay. So it's just a little bit of doing it that way. It gives you a little bit of a better idea about exactly, or roughly, how much you should get on your calculator once you've solved for this equation. Okay. So if there's any more questions about that, just let me know. But hopefully that clears it up a little bit more for you. Okay. Thanks. Bye.